I am Professor Raghavendra MJ, Department of Mechanical Engineering, SYT. Today I am going to give presentation on some of the topics on types of machines. The contents of the presentation are working of centrifugal governor and basic definitions and terms used in governors. Now this is the schematic diagram which represents working of centrifugal governor. Okay, this is the diagram. It's actually it is like a line diagram of centrifugal governor, and this is the throttle one. Okay, and which is connected to the slave through the bell crank lever. Throttle valve is connected to sleeve through the bell crank lever, and here the supply of working fluid happens. And this is this is connected to bevel gear of the engine. Now, once again, sleeve, it can move up and down. Okay, sleeve, over the sleeve, there is one more it is faced, and there are two links we have here. There's arms, we can say this is lower arm or a link. This is also lower arm or a link, and this upper arm or a link, and this upper arm or a link. And these arms are attached with fly balls on either side. There are two upper arms are there. These arms are attached to, sorry, these balls are attached to these upper arms. And these upper arms are pivoted exactly on the spindle. These are hinged at the common point. These two arms are hinged at the common point, pivot point on the spindle. And this is about the construction of this centrifugal governor. Come to the working of centrifugal governor. When the speed increases, I told you earlier in the function of the governor in the previous slide, when the speed increases, what happens? These fly balls will fly outside because of centrifugal forces acting on these balls. Okay, it will fly when the speed increases, these balls will fly out. And what happens? This slave will move upward direction because of increasing speed due to centrifugal forces acting on the balls. Okay. So what happens? Whenever the slave moves upward direction, when the speed increases, it will operate the throttle valve through the bell crank lever. Because when the slave moves, this bell crank lever arm also will move upward direction. Thereby, it will operate bell crank lever, and throttle valve will be closed to some extent to control the supply of working fluid to the engine. And hence, when this supply of working fluid, that is a fuel, is reduced, thereby speed is going to decrease. On the other hand, when this load on the engine increases, when the load on the engine increases, what happens? Speed decreases. When the speed decreases, what happens? This sleeve start moving downward direction. When the speed decreases, sleeve start moving downward direction along the spindle. Because when the speed decreases, centrifugal force acting on the balls will decrease, and hence the sleeve start moving downward direction along the spindle. Sleeve also will move downward direction along with the along the spindle. Thereby, it will operate the throttle valve through the bell crank lever, since bell crank lever is attached to the sleeve. So here, when the load increases, speed decreases, the sleeve will come down and it will operate the throttle valve, and it will open to some extent in order to supply the working fluid, that is fuel, to the engine in order to increase the speed. Thereby, whenever the load increases or decreases, it will control the speed variation by opening and by closing, by operating the throttle valve. We can say by operating the throttle valve and by controlling supply of working fluid, it will maintain the speed of the engine within the prescribed limit or constant. So this is about the working of a centrifugal governor. Next, some important definitions and terms used in the governor. First is height of the governor. What is the height of the governor? That is very important. Height of the governor is, in this figure I can say, it is a vertical distance from the center of the ball to the pivot point on the spindle where the upper arms, axis of the upper arms meets. It is called as a height of the governor, and it is measured parallel to the axis of the spindle. It is measured parallel to the axis of the spindle. Next, equilibrium speed of the governor. What is the equilibrium speed? It is the speed at which governor balls, arms, etc. are in the complete equilibrium position, and the slave will not move upward and downward direction at this equilibrium speed. Okay, that is called as a equilibrium speed. So at this speed, the governor bars, arms, okay, sleeves are in complete equilibrium position, or in complete equilibrium, and the sleeve does not tend to move upward and downward direction. That is, the sleeve, the arms, bars will rotate at a constant speed, and here the sleeve will not move upward downward direction at the equilibrium speed. What is the mean equilibrium speed? It is speed at the mean position of the ball or the sleeve is called as mean equilibrium speed. Maximum and minimum equilibrium speeds. Now, what is the maximum and minimum equilibrium speeds? At the maximum equilibrium speeds, the radius of the balls will fly out, and radius of rotation means from the ball center to the axis of the spindle. It is called as radius of rotation. The distance between center of the ball to the axis of rotation, axis of the spindle, is called as radius of rotation. When the at the maximum equilibrium speeds, what happens? Balls will fly out and they will start move upward direction due to increasing centrifugal force on the fly balls, and therefore speed, there's a radius of rotation increases at the maximum equilibrium speeds. And at the minimum equilibrium speeds, what happens? Centrifugal force acting on the balls decreases, and it will the radius of rotation also will decrease. Therefore, we can say uh, the speed at the maximum and minimum radius of rotation of the balls without tending to move either way are known as maximum and minimum equilibrium speeds respectively. So whenever you, whenever governor occupies some position at the maximum level, it occupies also the radius of rotation and remains same at that position. The slave will not move downward direction. That is maximum equilibrium position. When the speed start decreasing, radius of rotation also will decrease, and slave will come down, and at some position it remains say constant. That means at the minimum speed, radius of rotation also will be same, will be constant at the minimum equilibrium speed. That is called as a minimum equilibrium speed respectively. Next, stability of the governor. So what is the stable governor or stability of the governor? Governor is said to be stable when for every speed within the working range there is a definite configuration. That is, there is only one radius of rotation for the governor balls at which the governor is in equilibrium. That means it will not occupy any different radius of rotations for the different speeds, but it will occupy the same definite position, that is radius of rotation, okay, of the governor ball at which the governor is in equilibrium. That is, only one radius of rotation will be there for the stable governor. For stable governor, if the equilibrium speed increases, the radius of balls must also increase. That is directly proportional. Speed and radius of rotation are directly proportional. The speed increases, radius of rotation also increases for the stable governor. Next, sensitiveness. Okay, define sensitiveness. I will ask you, if a governor operates between the speed limits, that is N1 and N2, N1 is maximum, N2 is minimum, N1 is minimum and N2 is maximum, then the sensitiveness is defined as a ratio of difference between maximum minimum speed to the mean equilibrium speed. Sensitiveness of a governor is defined as it is a difference between maximum and minimum speed to the mean speed. It's called as sensitiveness. That is N2 minus N1 divided by N1 plus N2 divided by 2. N1 plus N2 divided by 2 is the mean speed. And the difference between maximum and minimum speed is N2 minus N1. Therefore, it is ratio of N2 minus N1 divided by N1 plus N2 divided by 2. That is called as sensitiveness of the governor. Isochronous governor. A governor is said to be isochronous when the equilibrium speed is constant for all radius of rotation of the balls within the working range. That means for any speed, any load, speed is constant and the also radius of rotation of the balls are constant within the working range. Okay, this phenomena is known as isochronism. And such type of governors are called as isochronous governors. A governor is said to be isochronous when the equilibrium speed is constant. Okay, for all radius of rotation. It may be any radius of rotation. Okay, it will be constant for all radius of rotation of the balls within the working range. Next, hunting. What is into hunting? So it is a phenomena in which, with a condition in which the speed of the engine controlled by governor fluctuates continuously above and below the mean speed. If the speed fluctuates, the engine speed fluctuates above and below the mean speed, this is called as hunting. It is caused by governor which is too sensitive and which therefore changes by large amount of supply of fuel to the engine. Okay, so now here in this hunting, what happens? The condition where the speed of the engine fluctuates about below the mean speed. It is caused because of the oversensitiveness or too sensitiveness of the governor. Next is ninth term is sleeve lift. What is my sleeve lift? As we know, whenever the speed changes, whenever the speed changes, that is increases or decreases, what happens? The sleeve also start traveling along the spindle. So that means sleeve lift is nothing but it is a total distance traveled along the spindle whenever the speed change happens or whenever the change in speed occurs. That is called as a sleeve lift. It is represented by X. It is a vertical distance which the sleeve travels due to change in equilibrium speed. It's called as sleeve lift. Governor effort. What is the effort? Effort we know. Effort is nothing but it is nothing but a force. Okay. Governor effort is the mean force exerted at the sleeve to rise it or lower it for a given percentage change of speed. So whenever the speed increases or decreases, there is a certain speed change happens. To that certain speed change, there will be some mean force exerted at the sleeve to rise it or lower it. That is called as a governor effort. Governor power. Come to the next 11th definition. Governor power. Okay, what is meant by power? Power, we know, effort into sleeve lift. Okay, effort. Governor power is nothing but there is a effort. There is a force into distance. Generally, we can say force into distance. Okay, force is nothing but here mean force, and the distance is nothing but a sleeve lift. The power of the governor is a work done on the sleeve for a given percentage change. So work done. Work done means what? We know basic equation force into distance, right? Work done. So it is a work done on the sleeve for a given percentage change of speed. It is a product of mean effort and the distance through which the sleeve moves. That is sleeve lift. That is given by effort into sleeve lift.